All right. So welcome everybody to Hoon School Live Lesson 2. I'm going to share my screen. Can everybody see my screen?
I do.
Cool. All right. Awesome. All right. 3 more people in the waiting room. All right. All right. So let's get started. The first thing I want to start off with today is just some tips for using the dojo. So as you guys have started doing the homeworks, you had to put things into your dojo, and hopefully I can give you some tips to help you use it a little better. If you go to your dojo and you press up arrow, that'll just scroll through your history of things that you've put in there. So yeah, and if you press the down arrow, that also scrolls as well. And if you keep pressing the down arrow, it'll just get to the blank interface eventually. So that's very useful. If you have an inward facing bracket like this, that means that you have an incomplete Hoon expression. And what you can do, so anything that you write here will be attached to the Hoon expression before, it won't be standing by itself. So what you can do in this case is either you can just complete the Hoon expression, or you can press backspace or delete, and that'll actually clear it as well. Some Emacs style binding. So you can press Control A to go to the beginning of the line, Control E to the end of the line. And if you have a running operation that's taking a long time, you can press Control C to kill it. Something that's pretty useful is that Dojo actually has autocomplete. So you can do this, if I forget how to spell commit, I can do this and press tab. And it'll actually tell me all the commands that I could complete this bar C with, like commit, code, cancel, etc. And so yeah, that's pretty useful. So you press tab to get the completion. All right. Cool. So let's get started with the hooning and knocking. So let's review last lesson a little bit. In last lesson, we learned knock formulas that look like this, right? So recall that it has 2 parts. Here we have the subject, which is like the data input to the computation. And here we have the formula, which is the computation that you're going to do on the data, right? So if we'll refresh our memories, this knock 5 says there's 2 formulas after the 5. Calculate both of these formulas on the subject, and then compare the results. Return 0 if they're equal and 1 if they're not. So how do I reduce this? I reduce this to 58902 and 58906. I compute both of those. And remember that knock 0 says, grab the to address of the subject. So this says grab the 6 address of the subject. And then we just grab this 50 and the 8 and we compare them, and they're not equal. So we reduce the whole thing to a 1. All right. So, oh, and some of you asked if there's a way to run knock code in the dojo, and there is. So you can run knock code in the dojo with this room. It's called .tar. The first argument is the subject, and the second argument is the formula. So we can even just run the code that we just went over in our dojo like this, 589.50206, and we get a 1. That's pretty cool. All right, so let's learn a few more runes that make Hoon's correspondence with knock even clearer. So this rune right here, let's look at this code in the dojo. So what's going on here if I run this? This looks kind of a lot like what's going on here, right? What's going on here if I run this? I get this send.n. This is what Hoon means for no or false. So this rune right here is called Tisgar, and it has two children. And the two children are basically the subject and some code to evaluate against the subject. So that's pretty much like knock, subject and formula. This next rune that we haven't seen before is called .tis. It takes two children. It runs both of these children against the subject and returns either a send.y if they're equal to each other, or a send.n if they're not equal to each other. So pretty much this Hoon code is exactly this not code that we showed above. And to show it to you even more clearly, so this is the 2 address right here, and this is the 6 address. If we change this, if we change this to a 50, then we get send.y. All right. So there's one thing that is a little different. So if you'll recall this not code, it says return 0 if they are equal and 1 if not. But here we have these constants send.n and send.y. So the first important thing to note about Urbit is that 0 means true and 1 means false. And so if we cast these atoms back to an atom, then the underlying integer, then we can just see that the send.y is actually a 0 underneath, and the send.n that's actually a 1. So these are just ways of interpreting the underlying 0, 1 in a certain way that makes it easier for you to read. It helps you understand that in this particular case, we actually need a Boolean truth value. All right, so let's go back to this .tis rune. You don't necessarily have to use it with this sort of addressing. You can use it with any sort of children. So for example, if we do this is saying, is 3, the number 3, equal to the number 2 incremented? If you run that, it says yes, 3 is equal to 2 plus 1. And we can just compare like values, right? Is 5 equal to 6? No, 5 is not equal to 6. And if we return to this Tisgar rune, we can do a few more examples with that too. So Tisgar says, we're setting this cell of A equals 1, B equals 2, C equals 3 as a subject. And in that subject, I'm just going to compute B. And that does what you expect, gets the number 2. And here, if I do this, here what this dot means, that just means return the entire subject. So this piece of code said, set the number 9 as a subject, and then just return the entire subject. So you get a 9. Tisgar also has a sibling called Tisgal. And Tisgal is basically just Tisgar but backwards. So if we do this, Tisgal B, A equals B, A equals 1, B equals 2, C equals 3, get 2. So it's just this backwards, right? And Tisgal dot. So are there any questions on that, on those 3 runes we just learned? All right, so if there's no questions, I'm going to keep moving. So why are we learning these correspondences to knock? Why am I placing emphasis on this? For example, you can learn the C language without really having to learn assembly, right? Which assembly is what's underneath C. However, Hoon and knock have a particularly close relationship where the structure of Hoon directly corresponds to the structure of knock. And in particular, knock operates under a paradigm called subject-oriented programming. And this is very unique among programming languages. Just like in the knock we saw, all Hoon is evaluated against a data context called the subject, which is a binary tree. In particular, when you run code in the dojo, the context is a huge tree which contains the whole state of your fake ship. So if I press dot, for example, that's going to take a long time to run because that's going to print out it's going to print out something very big. So it didn't take that long to run, but it prints out the whole subject, basically. So let's introduce some more runes that allow you to work with a subject a little bit. So here are the ones we've seen already. So we saw tis gar, we saw tis gal, and we saw tis lust in last lecture, right? So the new one first is called tis dot. It takes 3 children. It takes, the first child is something in the subject. The second child is a new value for that thing. And then the third child is doing something in this new subject. So basically tis dot says, let's take my current subject, change one thing about it, and then do something in that changed subject. So here's an example of some code. Here we have a tis gar, and we're saying set the cell a equals 1, b equals 2 as a subject. Then this tis dot says, let's take a from the subject, change it to 100, and then this dot says return the whole subject. So if we run this, then we get the cell a equals 100, b equals 2. Here's something kind of interesting. So what happens if I run this code? What's going on here? So let me make this text a little bigger. So we're saying set the cell a equals 1, b equals 2 as a subject, as before. Then we're saying change something in the subject, change this a to 100. And then you might recognize the syntax from last lesson. We're saying compute add a1. So you think this will return 101, right? But actually it says find.add Hoon expression failed. So what happened? This rune set the subject to literally just be this cell of 2 values. That's it. That means in this expression, we don't have access to the whole dojo subject. And the whole dojo subject is what contains the definition of gates like add. So if we use this rune instead, tis lust, this is different. This says we don't make this the subject, we pin this to the head of the subject. So we get access to this, and we get access to everything else that was already in the subject. So besides this change, that's the only thing that's different about this code and that code. And if we run this code, then we get 101, right? We change this a to 100, and then we computed add a1. Are there any questions on that? All right, if there's no question, I will keep moving on. So let's introduce one more rune. This one's called tis col. So tis col does exactly what tis dot does, but it does many of them at once. So you can, this is a rune that doesn't have a fixed number of children. All the runes we've seen up to now, they have 1 child or 2 child or 3 child, right? But this rune, it doesn't have a limit to how many children it can have. And so let's look at an example at how we might use this, all right? I'm going to make the text, actually. All right, so this is the first part of the expression. We're saying set this to be the subject with our tis gar rune. It has a equals apple, b equals banana, and c equals cherry, right? Next part of our expression is going to look like this. We're using this tis col rune. The first argument is something in the subject, a, and next argument is a new value for it. So we're changing this apple to be an avocado. next child is another name of something in the subject, a B, and then we're changing that B into berry. And we need to terminate this rune. Since we have a variable number of children, the Hoon parser is not going to know when it ends necessarily. So you have to use this tis to tell it that this is the end of the expression. So if we run this, oh, and the final child is the code to evaluate. So here it's just a dot saying return the whole subject again. So if we run this, we get A equals avocado, B equals berry, and C equals cherry. All right, so were there any questions on the usage of this tis call rune? Okay, so if there's no questions, I'll keep moving on. So we're going to introduce some terminology. So we've already been doing things like grabbing this A with this A, right? Basically, we refer to parts of the data tree in Hoon as limbs. Why the termination rune before the code to evaluate? Yes, because so this termination says it doesn't terminate this whole rune, but it just says this is the end of the pairs of things. So the tis, I should have put it in the graphic. The tis should go here, basically. And then the last argument, yeah, right. Yes, you can have infinite children. That's why you need it. But I think he was asking why this last child, this dot, is actually the last child of this tis call. And the tis was before that, because the tis signifies the end of these pairs of things. So I could have had a pair like 6 things, I could have 8 things, and then need a tis, and then after that is what you do with it. All right, so some terminology, yeah, just the syntax. A limb is the term for any part of the subject. So if like A here is a limb, B is a limb, like hep dot, or if we do like, that's a limb, and oops, that's also a limb. So basically limbs are just like kind of branches of this tree, right? What's called a wing is a search path consisting of limbs. So if we do this, we call this cell A. If you do bat.a, that's a wing. And we can continue sequencing these, right? Moo.bat.a, moo's inside bat, and get 2. That's also a wing. So the way I like to remember this is if you have like a skeletal structure of a wing, it has like a lot of articulated parts. So that's how I like to think about it. As you may know, Urbit has a lot of unique terminology. All right. So far, we've been writing our runes and expressions in a certain very constrained way, right? We've had expressions like this, right? Send hep, add, call hep, 1, right? And we've even on your homework, you've written like quite long expressions like this. Tisfaz x, send hep, add, call hep 1, tisfaz y, send hep div, et cetera, right? This is the most formal way of writing Hoon, with 2 spaces between runes and each of their children. And at a first glance, it's kind of difficult to parse something this huge, right? Like which things are children of which other things. It's possible to parse it, and it's important to have this sort of a skill. So, for example, looking at this giant thing, we would say, okay, let's start at the end. We have a call hep xy. That becomes a cell of x and y, right? Then we have this send hep pal, and then this argument to the pal. So this is saying we call the gate pal on the argument. So then we put these together. Then we go over here. This call hep 10.2 becomes a cell. These go together. And this senhep has 2 children. Yes, good idea. Let me put this in the chat for you guys, and you can run it in the dojo as well. So this senhep has 2 children. It's a gate call. The first child is a gate. Second is the argument, right? So these are going together. And then both of these, so there's this tisfaz, which has 3 children. Tisfaz pins a face to something. So the first child is a face, y. The second child is the value for that face. In this case, it's a result of calculating div 10(2), which becomes a 5, right? So we're pinning y to this expression, which evaluates to 5. And then the last child of this tisfaz is, we're calling the gate pow on xy. And we know what y is 5 here. So, and then finally, we collapse this tisfaz x in a similar way. X gets the value, add 1, 1, which is 2. And then so finally, we parse this whole thing as set x equal to 2, set y equal to 5, and then calculate the power of 2 to the 5. All right, so that was a lot of mental effort to parse this statement, right? And like this is the most formal way to write Hoon. And all Hoon is going to look like this underneath. We don't always have to write it this way. The way that we've been learning so far is called tall form. Every Hoon rune also has something called wide form. And to learn what wide form is, let's go through some examples for some runes that we've already learned. All right, so Cohort, as you know, So Cohort is just like Cohort 1, 2, right? And then the wide form is going to be like this. So we use this parentheses, and there's actually only one space between the arguments, like this. All right, so that's a wide form for Cohort. So dotless, that increments an atom. So dotless 3 is 4. We can also just write it like this. Tisgar, that's the composition we just learned, right? And we can also just write it like this. With just one space, not 2 spaces. So there's several others, but at this point you might see the pattern. So senhep add 1, 2. This is the wide form for senhep add 1, 2. So at this point, like you might pretty much understand the pattern for what wide form is, right? The important thing to note is that you can use wide form as a sub-expression in tall form, but you cannot use tall form as a sub-expression in wide form. So here's an example, right? So let's try to parse what we're trying to do here. We have a tisfaz rune on the outside. We're using the wide form, and it has 3 children. And we're trying to say, let x equals 2 in this expression, which is in tall form. It's saying senhep, call the gate div on the cell of 20 and x. So we're trying to do let x equals 2 in 20 divided by 2, right? But what happens if we try to enter this in the dojo? It won't let me run that because you cannot use this tall form inside of the wide form. However, if we use wide form inside of a tall form, so here we have a tall form for tisfaz on the outside, we have a wide form for senhep, and we have a wide form for Cohort. So if you try to write this in the dojo, let's 1 space. That's totally fine. So I'll copy paste that for you guys. All right, so that's just the most important rule to remember. Wide inside tall, no tall inside wide. Are there any questions on wide form? Yeah, so wide is, so tall has 2 spaces, maybe like T and T, and wide has 1 space. It's like a tall 2, wide 1. And like wide is, you're going to use these parentheses. That's wide form. And tall form is, you're not marking off where the rune starts and ends. In tall form, you're just relying on the Hoon parser to parse the number of children. There you go, big wide belly. All right, any other questions on wide form? All right, so yeah, tall is usually structured as slowing down the page, and you use line breaks instead of 2 spaces, so the code literally becomes tall. That's exactly right. All right, so in addition to wide form, some Hoon runes also have an even more readable compact version called sugar syntax. Not every Hoon rune has a sugar syntax, but a lot of them do, and the ones that do tend to be the ones that are more commonly used. So actually, we've already seen some sugar syntax already. We've used it without realizing what it was. So consider the Cohort rune makes a cell, right? This is tall form, wide form. And there's actually a sugar syntax, which is literally just form the cell. This is sugar for the rune. And there's also a second sugar for this, which is like this. We put the ket in between that, just like forms a cell of the 2 things. So let's introduce a few more runes in the Cole family. So in Hoon, we've been learning all these runes, and we noticed that they start with a certain character and end with a certain character, right? The way that runes are structured is that the same prefix means that they have a similar function. So in particular, any rune starting with a Cole is for working with cells. So we're going to learn a few more runes in the Cole family that allow us to work with cells. Yes, I will answer that chat question very soon. All right. So Colus, instead of making a double, this just makes a triple. So as if you'll recall, we made a triple in the following way, right? It's actually like 2 doubles nested. So a cell of 1 and the cell of 2, 3 is the triple 1, 2, 3. And we could also just use a sugar syntax like this, and that's just formatted as a triple, right? You can actually make it directly also with this Colus rune, 1, 2, 3, and that actually just sugars to this. Similarly for 4 tuples is the same thing. There's a rune for it. Please excuse my typo on the image. This would be Colket. But basically Colket 1, 2, 3, 4. That just directly constructs the quadruple. There's a wide form Colket 1, 2, 3, 4. And there's the sugar syntax, which is just literally this. And finally, there's a rune called Cohort, which handles anything larger than 4. And it just sugars to the same thing, actually. So the important thing to note here is that we can make these cells, like I can make 1, 2, 1, 2, 3, 1, 2, 3, 4, and so on, right? Although they look like they're the same thing, actually underneath, these are different runes. So this is Colhep, this is Colas, this is Coltar, this is Colket, and so on and so forth. Let's go back to our rune for calling gates. Senhep. This one also has a sugar version. You'll probably use this a lot. So instead of writing it in the long way that we were writing it before, we can simply do this, sub 4-1, like that. So you'll see this quite a lot. Let's introduce to a few more runes for calling gates. So this is a similar pattern to the call runes, right? These sen runes are for gates, for calling things, and the senless is for a gate taking 3 arguments. So if you recall, senhep takes 2 children, which is a gate and the argument to that gate, right? You can actually use any gate with senhep because any gate can be considered to just have a single argument, which is just a single noun that maybe has very many children, but it's just a single noun, right? So you can use senhep with any gate. However, if you know your gate takes a triple as an argument, for example, or sorry, a double, then you can use senless. So in particular, if I do this, I know that add takes a double, a cell of 2 things as an argument. So I can just skip the brackets and just do that. And in fact, I can just sugar this to the most compact. This is the easiest way to write it, and probably the way you'll see the most, just like that. So the important thing to note is what this actually desugars to underneath which rune. This is going to be senless. We can handle, there's a question in the chat. I wonder why you need Colket and Colas at all. Why is Coltar not used for everything bigger than 2? It's just for efficiency of notation. It's common to deal with 2. It's slightly less common. It's still common to deal with 3 and 4. With Coltar, since you don't know how many arguments it has, with Coltar, you don't know how many arguments, so you also need to include this tis to close the expression. Whereas if you know it's 4, then you don't have to include that. This will just parse as 4. So yeah, it's just efficiency. A lot of runes are just rewrites of other runes to save you time, basically. Yeah. So senket, I made a typo on this again, sorry. So senket is the same thing as senless. Basically, if you know that your gate takes a triple, then you can just use this, and then you can sugar it like this. Just A is the gate in this case, and B, C, D are the is a triple for the argument. And finally, there's a case for like every other longer case. Sen col. First argument is some gate. Next arguments are all the arguments within the noun that you're passing. And then it sugars to some gate x1, x2, all the way through xn. So again, the important thing is that we have these syntax like gate cell of 1, 2, gates 1, 2, gates AB, gate ABC, ABCD, and so on and so forth, right? And these look like they're doing the same thing, and you can't assume that. Like, you can just kind of look at this and understand what it's doing, but you have to understand that these desugar to different runes underneath. All right. Are there any questions on that part? All right. So there's one more sugar syntax for Hoon we've seen already. So we have this tisgal, right? And if you'll recall, this is just saying take the second argument as a subject and evaluate this first argument within that subject, right? It has a sugar, which is just B col A equals 1 equals 2. So you'll see that sometimes. And you can even do stuff like this, like pep dot pep col 1, 2. So this is the LARC notation, right? We're saying get the left branch so that it gets a 1. All right, so similar to wide form, we just learned that wide form can go in tall form, but tall form cannot go in wide form, right? Sugar syntax is the same. You can interchange sugar syntax with wide form, but you cannot use tall form within a sugar syntax. So for example, if we wanted to do this, like multiply 2 by the result of calling add on 1, 2, this won't even let me input it into the dojo. It says that's an error. However, sugar syntax under tall form is totally fine and good. So for example, we have the send less mol, and then we have the sugared add 1, 2, add 2, 3. That's totally fine. So it's great to use sugar syntax and wide form to make your code shorter and more readable, but always remember that there's a tall form expansion behind any Hoon code, and always know how to convert back and forth between them. And I'll have a link here in the chat if you want to read more about what we call irregular syntax. So any questions on that? All right, so if there's no questions, I will be moving on. So last lesson, we began our study of auras. So if you recall, every singular value in Hoon is just a positive integer underneath, right? But we can interpret that integer as different auras and get different results. So for example, if we want to interpret the number 0 as a pap p, we get Zod. Or if we want to interpret the number 0 as a text, we get the empty text. Let's introduce a new family of runes for working with types, which is the ket family. All right, this is ket. The first rune that we're going to learn is called ket hep. So what ket hep does is it takes 2 children, and the first child is going to be some aura or some type, right? And the second child is going to be some Hoon code. And it basically says, cast that Hoon code to that type. So, oops. So this says, take the text hello and interpret it as a pat, just an atom. And we can do sample helmet, and we can do the floating point, and so on, right? However, this is a little different because if this second argument doesn't nest under the first argument, you actually get a crash. You get a nest fail. We have here pat t, hello, and you need a pat p, and we crashed. So what's going on here? Hoon has a system of nesting for auras. So here's how it works. At the top, you have at, which is just the type of atom, right? That's the most general type, and that one can be cast to any other aura. For example, you can cast an atom to a pat U or a pat T, right? And the interesting thing is if an aura nests character-wise within another one, then this one can be cast to that one. So you can cast a pat UD with kethep to pat U, and you can cast a pat U to a pat, just a pat with kethep, but you can't cast a pat T to a pat U. You can't go like this because it doesn't obey the tree structure, right? So this isn't all the types in Hoon, obviously, but this is just an example of how the nesting. So if something's under something else, then you can cast it to that. Yes, exactly. So let me show you, well, down the tree, not necessarily, but up the tree. Yes. So let me show you some examples and maybe we can understand this a bit more. So here I have a hexadecimal value, 0x ABC, and hexadecimal is a pat UX, nest under pat U, so I can kethep it to a pat U. And this gets the integer representation of that hexadecimal, right? But I can't do this with like a pat T, for example, because UX doesn't nest under T. But if you'll recall, I was actually able to use this syntax to turn that, I was able to use this syntax, right? Well, that says bad text, but I can do this. So what's going on there? So it turns out this notation with the ticks is actually sugar for a double application of kethep. So in particular, if I do tick pat UX tick hello, that desugars to this. I'll put those both in the chat. So this saying, let me take my hello, this text. First, I'm going to use kethep to pull it all the way up the tree to an atom. And then I'm going to take that atom and an atom. So for atoms in particular, you can go down the tree. And we're saying take that atom and then cast it to a pat UX. So this is okay. Are there any questions on this usage of the kethep room? Basically, the function of this rune is you'll quite often have some code that does a computation, and you'll say like, I need this code to return a certain type. Otherwise, like, I want this to crash because it's not doing the right thing, right? If you're writing some app, you need to return data that fits a certain pattern, right? Yep, exactly. So this inner kethep is stripping the hello of its type. And then this outer kethep is taking that stripped text and then casting it to a pat UX. Yep, so this is sugar for this. All right, any more questions on that? So let's learn a few more cat runes that allow us to work with types. So our next rune, called ketless, is very similar to kethep, except instead of specifying the type in child 1, you actually give it a Hoon expression. It'll infer what type that is, and then it'll use that to cast child 2. So let me show you an example right now. So here I have ketless, Zod, senhep add colhep 1 2. So we know what this does, right? This is going to return 3. This is a planet, right? So what happens when we press enter? We get Wes. And Wes is the planet for the number 3. So this is saying, I know that Zod is a planet, so I'll take this code here and cast it to a pat P. And the equivalent, if we wanted to use kethep, would be just like this, right? And something else that we might want to do with these types is like get a default value for a certain type, right? This is very useful when you're writing apps, like you say you have an empty data table, you need to fill it out, or just have a default return value or something like that, right? For that, we use this rune called ketar, and yeah, I think that's actually incorrect. Sorry about that. But basically, ketar just does. Yes, well, yes, that's correct. Galaxy, not planet. So ketar pat p just gives you the default value for pat p. Ketar pat da gives you the default value for date. Ketar pat t gives you default text value. And there's a sugar for this, which is just simply tar, like that. Tar pat da. All right. So finally, if you recall, we've previously created cells with faces attached to various elements like this, right? Like the cell A equals 1, B equals 2. So it turns out this A equals 1 syntax is sugar for another ket rune called ket tis. And the first argument to this is going to be a face, and the second is going to be a value, and it returns that expression with the faces attached. So if I just do ket is A1, that is the same thing as a sugar A equals 1. Interestingly, it can also pattern match to cells. So for example, if I do this, ket is the cell of two faces AB and the cell of two values 1, 2, then it'll apply both of those, like so. You can even do this for more complicated things. So the cell of A and the cell of BC as faces, and 1, 2, 3, 4. Then I'll attach A to 1, B to 2, and C to the cell 3, 4. And I can even do like this and attach faces to that inner X and Y. If I put this in tisgal, we're saying attach these faces with the ket tis and then evaluate X of C. So we're attaching X to 3, C to the cell 3, 4. So X within C is going to give us this 3 back. All right, so that brings us to the close of the section about ket runes. Have there been any questions on that? All right, so I'm about to introduce an interesting feature. Yes, I will copy these to the chat. Yeah, and you guys can play around with that if you like. All right, so Hoon has one interesting feature of the Aura system. There's a distinguished type called pat-TAS, or otherwise known as term. So if we just judge from the name pat-TAS, and if we go back to our tree here, from what we just learned, we can infer that pat-TAS can nest under pat-T. So every pat-TAS should be valid as a pat-T, but not necessarily the other way around, right? And that's just from looking at the name of it, we can infer that. So that's in fact true. A pat-T, which is called a chord, can be any UTF-8 Unicode text. So we can do cat hep pat t, like all sorts of symbols, right? And that's totally fine. However, a pat TAS can only be the lowercase alphabetical characters, a hep, a dash, and the numbers 0 through 9. And the first character has to be alphabetical. So if we try to cast this to pat TAS, well, that shouldn't have worked. But anyways, I'll figure out why that is doing that. But basically, a pat TAS has to be of this form. It's like ABC1. And so on and so forth. The special thing about terms is that every term, every send something is a type in and of itself. For example, I can actually cast this like send ABC is a type send ABC. But if I do this, it actually fails with a type error because it says we have a type send ABC and we need a type send AB. These sorts of terms as types are used all throughout Urbit's core system and apps. So we'll get used to using these in the next few lessons. Finally, I will show you a useful tool to use if you're ever unsure about the type of something in Hoon. So Zapgar, this rune takes one child, which is just some noun, and it returns a cell of type of noun and the noun. So if we do Zapgar, this binary number, it'll say, this is a pat UB. If we do Zapgar hello, it'll tell us this is a pat T. And if we do Zapgar send some term, here it says, actually, this is a type of some term. So just as we just learned. All right, so there's more content that I was thinking about getting through on molds, but I think we have about 6 minutes left. So I'll save those for next lesson. I'm gonna drop the anonymous feedback form in the chat. Feel free to roast me if you like. Any questions or concerns, definitely feel free to put it in there. Yeah, so have there been any questions, any last things on the lesson today?
Could you repeat what's the tis hep?
Yeah, tis hep. I don't think we learned this rune.
No. I hope. Yeah, the one that you were when you showed T dash E, it's actually the percent. No, the hat dash.
Oh, ketis.
No, cat hep maybe. Yeah.
Okay, yes. So this is a very important rune. This is called a fence. So the first argument to the fence is a type, and the second argument is some computation, and it says, is this valid as this type? If so, it returns this computation as this type, and if it's not valid as that type, then it crashes.
Right.
Crashes.
Thank you.
Yep. So this is a very important rune. It's when we start making gates, which are like scripts that you can call. When you start working with apps, you'll use this rune throughout to make sure something is the right type. Yep. Thank you, Jack, for a very useful comment in the chat on PatTAS. All right, so the reason basically this if we did like send something, it doesn't work. This won't even let me input it. If I try to do capital, but if I just do heps and numbers, that's totally fine. So yeah. All right, any other questions? I'll also be in office hours, about 15 minutes. It'll be in the Urban Hacker House. So yeah, definitely feel free to catch me there. If you have homework questions, I'll be there. So yeah. All right, I think I'll end recording for today.